Hey guys, so today we are going to look at a couple of diagrams when it comes to convex lenses. Okay, so we have already looked at ray diagrams in terms of mirrors. So majorly we looked at what a concave mirrors ray diagrams will look like. Today we are looking at what a convex lens diagram will look like. The principle is the same. What we did there, we are going to do same here. We know already what rules of refraction are there. We also know that object can be placed at different points in front of the lens, and image will be changing based on where the object is put, right? So similarly we are going to have it for lens. Today we are having a few diagrams, half of them. We are going to focus on three. You practice them well, then we can go ahead to the next one. Alright. So this topic is ray diagrams of convex lens. Alright. Now the first diagram is quite simple. Right? It's something we have already seen. What if my object is at infinity? By infinity, we simply mean it's very far. Okay, like the sun is at infinity from us, similar, or just really far from the lens. Okay, so for every single diagram, we'll have this format. Keep in mind, I'll tell you the rules for it. Right, you have the lens, you'll have the focus, you'll have the C, another focus, and another C. Make sure these distances are equal. All four of these should be equal to each other, or else a diagram will not come properly. Okay, now when I say object is at infinity, the light coming from the object comes in parallel lines. Okay, like this. So we know from rule 1 that any line that is parallel, it just refracts and goes to the focus, right? Like this, like this. So the object might be really far, but the image of that object is at focus. But it's a really tiny point sized image. Okay, so whenever this is the case, we will say it is a point size image which is formed at focus, right, at that point exactly. We can't really tell whether it's inverted and all that because it's too small to see. So the second case, I'll bring the object closer to the lens. So I'll say object beyond C or behind C means the same thing, right? Which means a little behind this. So, principal axis, lens, F, C, F, and C. What about the numbering part? 1 and 0. Right? You can switch them, it doesn't really make a difference. Okay. Now, say my object is beyond C, which is somewhere behind it. I'll draw it over here. Okay. Now, I will draw the ray diagrams to any two rules. Okay. The rule that I am going to use are these. First is parallel. Okay, going parallel to the axis. After refraction, the rule says it has to go to focus. Right. So this is my refracted ray going like that. Now my second ray, I am going to take this rule that says, I'm sorry, I think I might have mixed up the numbering for you. It's not exactly the first rule. First rule is on principal axis, right? I think that's the third rule, and that's okay. The numbering doesn't matter long as you know which rule says what. Okay. Also, please do not mind that I look a little sick. I've been sick, so I hope the sleepy face is fine for you. Alright, so this rule says my ray of light goes to the optic center, right? The exact middle of the lens. Make sure you're using a scale to draw these diagrams, okay, or they will not come correctly. I don't have a scale, so I just have to approximate. There. Now, these two rays after refraction are meeting here, right? All you need to do is draw your image over there. So my object is an arrow here, the image is an arrow over here. Which is a slightly small arrow. If you see, this arrow is a bit bigger than this arrow. So this tells me that the image is smaller than the object. Alright, so I will call it diminished image. And it is formed between F and C, right? Between these 2 points is my image. This is nothing but object image, object position, image position, and nature, right? Remember diminished, inverted, and all, right? So if you see again, this arrow is upright, but the image is upside down. So I will call it inverted, meaning reverse, and real. Okay, because it's formed on the other side of the lens, and we can actually see that. For the next one, I bring the arrow a little more closer and put it on C. Okay, object is exactly on C or at C, if you can call it. If you see, they correlate very closely to the mirror table also. If you remember that, you'll be able to make connection. So in a way, it's not something very new, something you've already studied a while ago. Right. Let's keep an object here at 0. Right. the same two rules. Okay, I will remove this. First ray goes through focus. Right? What about the second ray? It will also follow the same path, which is the through the optic center, which is kind of like that. Alright, so if I see where these lines meet, not very neat, sorry for that. But if you use the scale and the right measurements, you will see that they meet exactly under C. Right? Now, whenever the object is at C, the image will also be at C and then be about the same size. Okay, about the same size. So, whenever the object is at C, I will say the image is of the same size as object. Okay, and it is found at C. This image is also inverted, so I will call it inverted, which is reverse, and it's still a real image because it's found on the other side of the lens. Okay, so these are three diagrams, three situations of object. The remaining we are going to do tomorrow, which are also quite simple, right? We will pretty much the same rules. Alright, so that's it for today. I'll see you tomorrow on the next one.